This is lesson 2 of the second unit of the first quarter. So we say Q102, and this is lesson 2. Okay, we're going to start off by reviewing some important limits and important identities. For the first one, the limit as h goes to 0 of sine of h over h. You can show this numerically, graphically, but the answer is 1, which you may recall. And the limit as h goes to 0 of the following is equal to 0. So those are two properties that you should know. At the bottom, identities, the sine of x plus y is equal to the sine of x times the cosine of y plus cosine of x sine of y. And then finally, the cosine of x plus y is equal to the cosine of x cosine of y minus sine x sine y. Okay? So you should know these. If you didn't, you should know them now. You should memorize them as we move forward. The first thing that we're asked to do is to find the derivative of the sine of x. Now, eventually we're going to commit these to memory, but initially we need to derive what their value is, what their function is, and the only thing we have are these properties above. So, in lack of memory and with these properties, the only thing we can use is the definition for derivative. So the definition of the sine of x is equal to the limit as h goes to 0, the sine of x plus h minus the sine of x all over h. I would press pause at this point and see if you could do it from here, because this is essentially a deeper level thinking problem. So I'm going to use the sine property, and this is going to be the limit as h goes to 0, sine of x cosine h plus cosine x sine h. That's using the sine of x plus y property. Then we still have minus the sine of x, that's this sine of x here, and then again all over h. Next, we're going to write this limit statement as the sum of limits. So I'm going to write it as sine of x cosine h minus, let's take the sine of x portion of this over h, plus the limit as h goes to 0 of the cosine of x sine h over h. Hopefully you can see here in the first of the two limits that we're going to factor out a sine of x, and I'm then going to write this as the product of limits. So the limit as h goes to 0 of sine of x times the limit as h goes to 0 of the cosine of h minus 1 over h, plus now the second one I'm going to write as the limit h goes to 0 cosine of x times the limit as h goes to 0 sine of h over h. Sweet. So at this point, I'm going to look at the first of the two in the first product, and h is going to 0 sine of x. Well, h is varying and sine of x is treated like a constant, so that's simply sine of x. From the identity above, well, if I want to be a good technician here, I want to say negative limit h goes to 0 of 1 minus cosine h over h. I factored out a negative 1 there, plus cosine of x is treated as a constant, and from above this one here is equal to 1. So lastly, we have sine of x minus 0, times a negative 0, which is still 0, plus the cosine of x, which gives us the cosine of x. So the derivative of the sine of x, I'll just summarize here, the derivative with respect to x of sine of x is actually the function cosine x. Next we look at the derivative with respect to x of cosine x. Press pause and see if you can find what that derivative is, then unpause to check for your work and answer. And here we go. Here's the work. Very similar steps. You'll notice here that I again factored out a -1 so that I can see my property. And the final answer, the derivative with respect to x of cosine of x is negative sine of x. After this lesson, you are expected to commit these to memory. Okay, next we want to derive the derivative with respect to x of tangent of x. We're not going to use the definition. We're not going to assume the answer, but we are going to use what we know up to this point. So the derivative with respect to x of tangent of x is equal to the derivative with respect to x of, well, let's write what tangent of x is. Sine of x over the cosine of x. Now in order to find that derivative, can you guess what we're going to do? Quotient rule. So bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared, which then comes out to be cosine of x times the derivative of sine, which is also cosine x, minus sine of x times the derivative of cosine, which is negative sine, so that becomes a plus, all over. And then in the numerator, we have cosine squared of x plus sine squared x, and that should ring a bell to you, over the cosine squared x, which comes out to be 1 over cosine squared x, or also we could write is equal to secant squared of x. So there it is. The derivative tangent of x is equal to the secant squared of x. And I'd like to do one more derivation. The derivative of secant of x. So in similar fashion, we're going to write some identity for secant of x, or some definition of secant of x. And so this is going to be the derivative with respect to x of 1 over cosine x. And we're going to employ the quotient rule once again. So we have bottom times the derivative of the top minus top derivative of the bottom all over the bottom squared. And let's see, that's going to equal, well, the derivative of a constant is 0. So this is 0 minus the derivative of cosine is positive sine, is negative sine. Together with this negative makes it positive sine, all over cosine squared. So sine x over cosine squared x. If I break that down into 1 over cosine x times sine of x over cosine x, then it gives me an answer of secant of x times tangent of x. You should find a page in the notes for something called a book of memories. That means I want you to commit it to memory, and I want you to commit it to memory now. It's very important. You will wrestle for the rest of the year if you don't commit these to memory. So, let's review. Derivative of sine of x, we found to be cosine of x. The derivative of cosine of x, we found to be negative sine x. Of tangent, we found to be secant squared of x. Can you guess what the derivative of cotangent of x is? You can always derive it. And it will be negative cosecant squared x. Derivative of secant, secant x, tangent of x. Can you tell by the pattern what this will be? Take a guess. 3, 2, 1, negative cosecant of x, cotangent of x. Book of Memoirs. Memorize it. Finally, we're going to look at 3 examples from the notes, and the first one is f of x equals x squared times the tangent of x, and we're asked to find f prime of x. I would do it and then press pause. So we have a product here, so I'm going to use the product rule. First term times the derivative of the second plus second term derivative of the first. So we have x squared times, if I've committed this to memory, secant squared of x, I know the answer, plus tangent of x times 2x. I'm interested at this point that you know all the rules, so we can leave it unsimplified like that. If you can't help yourself and say, well, I'm just so used to this, then please put the 2x in front of the tangent of x, because that is actually customary. Number 2, example number 2. We want to find dy dx if y is equal to sine of x over 1 plus cosine of x. Good old quotient rule. So dy dx equals bottom derivative, I'm be consistent with notation here, derivative of the top minus top, the derivative of the bottom all over bottom squared. Quantity squared. Okay, so what is this? 1 plus cosine x times cosine x minus sine x times 0 minus sine x, so that will make this a plus all over squared. Now normally I don't simplify it, but this one is just so delicious that you have to simplify it. So take a moment and simplify it, and then check your answer. So if I distribute, I have cosine of x plus cosine squared of x plus sine squared x over 1 plus cosine of x squared. Now I'm going to come over here with it, and then we have, because of this equaling 1 plus cosine of x over 1 plus cosine of x squared, which gives us our final answer, 1 over 1 plus cosine x. Yay. Final answer. Pardon me. Final question. We're going to find, see the 2 primes of here? We're going to find the second derivative of y with respect to x if y equals the secant of x. Alright, let's first find the first derivative. So y prime is going to equal the derivative of secant, which we have committed to memory, which is secant of x tangent of x. Next, we're going to find the second derivative of y, and we have to use the product rule. First term times the derivative of the second, and the derivative of the second, the derivative of tangent, is secant squared of x, plus second term, tangent of x, times the derivative of the first, which is derivative of secant, which we know is secant x tangent x. And at this point, let's see. I'm going to keep this secant x, secant squared x, plus secant x tangent squared x. So that's y double prime. So what we need to do now is find the value of that derivative at pi over 4. Meaning, let's not forget the interpretation, that's going to be the slope of the tangent to this curve at pi over 4. That's going to be the instantaneous rate of change of this function at x equals pi over 4. And this just has us recall some identities from last year. So the cosine at pi over 4 is equal to square root of 2 over 2, which everyone should know. So the secant of pi over 4, well, let's write this out. Just write out like that. So the secant of pi over 4 is 1 over radical 2 over 2, or simply 2 over radical 2. Then if I take that value and square it, I'm going to get 4 over 2. And then we have again 2 over radical 2. And then the tangent at pi over 4 is equal to 1. Squared is still 1. So in the end we have 4 over radical 2 plus 2 over radical 2, which is a total of 6 over radical 2. Now you can leave it like that. There's no reason we have to rationalize the denominator. I will, just in case that's how you're comfortable with finishing it out. So this is going to be 6 rad 2 over 2, or 3 radical 2. That's the end of this short lesson. You have some additional called additional problems. Those are for homework, and I will send an email with homework or write it in class.